Alright, in the last video we had talked about the idea of interference, with constructive interference being when the wave crests meet up and the wave troughs meet up from multiple sources and give us large waves, large wave amplitudes. And then there's destructive interference, where you get the wave crest and the wave trough lining up with each other and they cancel each other out, or at least cause a smaller amount of a wave amplitude. We primarily focused on the ripple tank at falstad.com, and this was the last image that you saw. And we can just do a quick review here. Basically, there will be more maxima and minima, more areas of constructive and more areas of destructive interference when you have a larger frequency. What we're seeing now is actually the residual effects of the original frequency that I had, that very slow frequency, lingering and still affecting things. So I'm going to clear the waves so that we can see the view of just these ones. And it's very apparent here. These gray areas are areas of complete destructive interference, and the areas that look much stronger than that look like there's a larger wave amplitude, those are areas of constructive interference. And then in between, there's kind of normal waves. They're not really constructively, not really destructively interfering with each other. It's a combination that gets us to kind of a baseline level. Now, we could also do other things. For instance, on this website, you could go to two sources with two different frequencies, which you can change the phase and essentially do that. You can also do, say, 4 sources. So I'm going to clear the waves here so you can see this. I'll go to the 2D view at first, and I'm going to lower the frequency down. That's a little too fast of a frequency for me. And you can see all the interference patterns now, and it's actually pretty crazy. And if you look carefully, for me, I see kind of like a 4-sided star in here from the interference patterns, and there's squares and so on flashing in and out. And as you change the frequency, those interference patterns change quite a bit. Still the same idea of getting sort of these peaks now of constructive and destructive interference, and they might actually be changing place. Actually, no, it doesn't look like they are. Looks like we're maintaining sort of areas of destructive interference and areas of constructive interference. And this is what the 3D view will look like. And so it kind of looks like egg cartons, egg crates. So it's pretty crazy in terms of the way that it looks once you start to introduce multiple sources. And you can play around with this. We're going to be looking at some specific examples for some other phenomena later on. But I encourage you to play around with this and get a sense of how the interference patterns work. Now what we're going to do is look at some simulations. This is the second site, the FET site, and it deals with sound waves specifically. And here's this guy, and you can move him around side to side on this first tab of listen to single source. I can enable the audio. I'm not sure that you guys can really hear this if I play that. What I'm going to do is, when I really need you to hear things, I'm going to turn up the volume and put the microphone right up next to the earphones. But you can change the frequency if you want to, and that'll make things lower frequency or higher frequency. One of the neat things is that there's a delay. You can see the waves here. And when you play with this yourself, you'll realize, you'll notice, well, I made the frequency really high. Why does it sound the same? Well, you're not going to hear it change if you have it on the listener until those higher frequency waves actually hit the listener. There's this measure tab. I'm not going to really do much with that. What we're going to focus on here is the 2-source interference. And you can see this. This is kind of like that 2-dimensional view from the ripple tank, where you have these areas of constructive and destructive interference. And it's pretty easy to see. Hopefully you're decent at it by now. This sort of gray area, a middle gray, the colors aren't quite as clear here, but there's kind of this like very light gray and very dark gray. And if it's kind of a middle gray that looks kind of like a straight line in these areas, right here, for instance, and right over here, those are the areas of complete destructive interference. And what I mean by complete destructive interference is hopefully you'll be able to hear it in just a moment. What I'm going to do is I'm going to center this guy right around there, and I'm going to actually, maybe I should put him a little bit off to the side. I'll put him in an area of constructive interference first, and then I'm going to move him around. And hopefully what you'll hear is the effects of constructive and destructive interference given sound waves. Alright, hopefully you were able to hear that or not hear it at various times. Hopefully what you could detect was that when I moved him to one of those areas where there's kind of just this bland gray line, you couldn't hear anything. There were a couple spots where I couldn't quite get it right, and maybe you heard a very faint sound, but then I'd move him slightly off to the side of that gray line, and he'd be encountering the constructive interference segments, where you have a strong wave meeting another wave and a strong trough meeting another trough. And as I just moved him around to these areas, even when he was almost right in front of, it was actually this one down here, there's an area where the waves are destructively interfering with each other. So even though he was sitting right in front of that one speaker, he couldn't hear it. And this is something that can happen with sound waves. And you'll see it with, for instance, noise-canceling headphones. One of the things that they'll do is they sample the sound, the ambient sound in the area, and then they invert it. So when they initially record the sound, and they kind of invert it close to real time, so that when the sound is entering your ear, they're playing something also into your ear, another sound wave into your ear, that's almost exactly the same as the sound that's entering your ear from outside, only inverted. And that causes this destructive interference. Alright, to take that last idea with the noise cancelling headphones just a little bit further, I'll show you an example. And let's say that your ambient sound, which I'll do in this greenish bluish color, maybe your ambient sound looks sort of like this. Now this would be a very regular ambient sound. Whoops, maybe not so regular after all. And it looks something like this. Okay, so it's pretty consistent, and normally ambient sound actually is. It's just kind of this noise, and it's fairly easy to replicate it and cancel it out. Well, to play back the inverted sound, it's going to be off by a little bit. It's going to take your noise canceling headphones a little bit of time to adjust to it. Not a lot of time, but maybe a little bit. So there's a couple ways it could do that. It could try to play it one out of phase, but that's pretty hard because this is, like I said, a very unusual too regular ambient sound. So maybe it does this. Where it's not quite perfectly canceling it out, but it's getting okay. It's doing an okay job of it. So what we would see is we would see an overall wave that would look sort of like, and let me make this a little bit thicker here, that would look sort of like this. Up, down, and so on. It just kind of wiggles around. Okay? So it's not that it's gone. It's still there. It's just that it's not going to be nearly as loud. And the better your noise cancelling headphones are, the better they're able to replicate and invert quickly. So that's one of the technologies that use this idea of destructive interference. And it always seems strange to me that you're hearing the sound that's being played into your ear, and you're also hearing the sound around you, And because you're hearing both of them at once, you actually don't hear anything at all. So by playing two sounds into your ear, it's getting rid of them. Now, if we go back to this one for just a minute, one of the things you'll notice is that there are these areas of constructive and destructive interference, and this is at 525 hertz that it has this particular pattern. But if we go to a lower frequency, and this might be more of a bass frequency, the pattern of destructive and constructive interference changes. It actually becomes a little bit difficult to see where it is on this sample, but you can look at Falstad and see a very similar effect. But you can move him around and listen to the effect that it has at a low frequency, and you could also then go up to a higher frequency sound and notice the effects that it has. And what this means is that if you're actually playing real music, and let's say you're setting up for a party, and you want, well, a lot of you will be going off to college in a year or two, so maybe you're going to be in charge of the sound systems at a party. You want to be careful about how you set up your stereos, because if you set them up too close or too far away, you're going to get more destructive and constructive interference, depending on exactly what the wavelengths are. So you have to be careful about understanding that it's going to be possible for somebody to be maybe here and not be able to hear the higher frequency notes, but be able to hear a lower frequency sound just fine, and actually here he's missing out on both of the high and the low frequency sounds because of the arrangement of the speakers and those particular frequencies involved. But it is something that if you want to be very good with acoustics, you have to take into account the fact that the sound waves from the speakers will at times cancel each other out and will at times build each other together. So there's actually a study in a major in physics that's acoustic physics, and there's acoustical engineering and all that type of stuff where they focus on not just this issue, but this is one of those issues, because you don't want to set up your speakers in such a way that you're getting lots of constructive and destructive interference, particularly at the frequency or at the frequencies that are likely to be involved, and particularly where you want people to hear or not hear what's being done. So this is very important for setting up concert halls and auditoriums and that type of a thing. In the next video, what we're going to be doing is we'll be looking at some more stuff really with interference. And so hopefully if you don't quite understand interference at this point, do a little bit more reading on it. There are a number of sources online that you can go to, or rewatch some of the videos if you don't quite get the idea of interference. Definitely play with this simulation, and also work with the Falstad simulation.